Hello, I'm George Jenkinson, a PhD student at the University of Bristol. I'll be presenting our paper, A Pressure-Controlled Membrane Mechanism for Optimizing Haptic Sensing. This is a part of a wider project that we're doing in partnership with Cancer Research UK, with the purpose of creating a device that's capable of interacting softly with human tissue, but that can also change its own stiffness to interact with harder stimulus, for example, from fat to bone. Currently, the device blueprint looks something like this. It will have a sensory interface as its interface. So here it's been modeled as a piston, but this could also be a soft, deformable interface. An incompressible liquid that the interface is connected to, and some air at the end. And the proposed mechanism is that when a force comes into play at the sensory interface, the liquid is moved, the air is slightly compressed, and we can measure the change in length of the meniscus position of the liquid and work out the force at the end. And we can measure this by using a camera, for example, or we can measure the flow. The work we present here is independent of the sensory modality. So a sensory device in general may be characterized by its sensitivity to small changes to a stimulus, and also by the range of stimuli to which it is sensitive. So it's generally advantageous for a sensory device to be able to enhance its sensitivity and also to extend its sensitive range. In this device, the sensitivity is not homogeneously spread over the sensitive range of the device, which I'll now demonstrate a bit further. So at first, the piston is very easy to push, but it becomes stiffer as the air is compressed and acts like a pneumatic spring. So when the air is compressed, up here on our graph, a large amount of force only results in a small amount of change in volume, whereas at the beginning, a small amount of force results in a large change in volume. So this is when it's most useful, when a small force has a large change, and when it's least useful is when a force only has a small change. So one thing that we are proposing to change this is that we can add ad hoc volume of air to this right-hand side, and in doing so, we can move from this blue force volume landscape to a shallower one. This yellow landscape here, and you'll see at this point of applied force, it has a higher gradient and is therefore more sensitive to forces around this range. There are an infinite number of landscapes that we can move between, and we can choose which one to move to best suit our purpose at the time. Thanks for listening.